The next couple of lectures will be on shell programming and shell scripts, and once we're done with that we will move on after that to C programming. So for now we'll look at shell scripts. This is a lot of this material is from the textbook chapter 12, but I've added some additional material too. Okay, so most command shells can run shell programs. Windows, you can have batch files. Some of you may have used batch files. They're just a list of commands that you would normally type in at the command prompt that you put into a file and then run that file. It's just like running all the commands that are in there. So Windows can do this kind of thing. We can do the same thing in Linux, also in Mac OS X. This gives us options to accomplish tasks. We can use C or other high-level languages or a shell program. Let's take a quick look at some of the differences. So here's a simple example. Here on the left side is shell script, and we will stick with bash shell scripts for the rest of the semester. If you're going to run shell scripts, we will just use bash. If you really want to, you can try some other ones, but all of the homework assignments, all of the labs are going to assume that your shell scripts are in bash and they have to be to get credit for them. At the same time, all our programming, that's high-level programming assignments, will be in C. So here is a C program that does basically the same thing the shell program does. So what this does is, okay, so here this first line allows you to use input and output. This is to open up a file that's passed in as a command line argument. It will read it, it'll open up the file in read mode. It will take up to 200 characters from the first line and then print it out and then close the file. Here is about the same kind of code that, actually a shell script that will accomplish the same kind of task. What this will do is it will check if the first argument to this script is a file. That's what this is doing. If it is, then read a string from that file into this variable x and then print it out. So they basically do the same thing. Now the only thing you want to get from this, you don't have to know all the details, it's just that this is fairly simple to write. And once you write it, all you have to do is set that file, wherever this is, to be able to be executable, and then you can run the program. No problems. On the other hand, for this program, it's just a text file, but then you have to compile it, you have to create an executable. Now you have two files you have to deal with, and then you run the executable file. So while this will do exactly the same thing as here, or pretty much the same, I think on the whole, for this particular task, if you want something working quickly, I think in this case, this shell script is a better alternative to a C program. Okay, so we looked at we quickly took a look at the differences between a shell script and a C program. We will get to C programs, but there are situations where a shell script might be better. So what exactly is a shell script? A shell script is an executable file containing shell commands. It is a program written in a shell programming language. So the thing is, it's not just a list of commands. It can also have things like if statements and loops. That's what make it really valuable. So a shell script executes commands in a file sequentially, just like you would in a regular program, but it may also contain control logic in a high-level language like C or Java. So a high-level control logic like if statements, loops, things like that. Script files they're ASCII text files, just like C programs, C source code. And unlike C source code, they don't have to be compiled, they're interpreted. So They're ASCII text files. They're not binary. You don't have to create a binary from a script file. You just run it as long as you can have execute permissions set. So all you have to do is set execute permissions, and actually you don't even have to do that, but that's the way we will do things. Okay, so what are some shell programming constructs? Shell programs can have some of the typical programming constructs like selection, that is if statements, switch statements. Actually they're called case statements in shell scripts. Also you can have iteration, that is for loops, while loops, and until loops, just like Java or C. Okay, an advantage of shell scripts is that they are easy to execute shell commands and programs in a script. So here is a simple example. This came from a Wikipedia page on shell scripts. You might want to check it out. And I think I slightly modified it, but it's basically the same idea. So this is a shell script, and it has the main thing in here is a loop. It goes from here, from this for statement to the done. And what it says is essentially it prints out a line saying converting JPEG file, and it basically looks for files that end in JPEG, and it converts each file that it finds to a PNG file. So it converts JPEG to PNG files, and then it renames them. If the convert works, it just goes on and fetches the next file and does the same thing. Else, it prints out an error message saying that it's not able to convert this file. Okay, so what's the nice thing about this? This is a very simple program. It can be written, 10, 20, maybe 30 minutes, and you can debug it really quickly and run it. It is using a C program, like convert is a C program, and it is using that C program internally, but the idea is that the C program stays nice and simple and doesn't do anything that complicated, and we put it inside a script to do more complicated things. So the C program does one thing really well, that is to convert the format of a file, in this case from JPEG to PNG. And the script does all the fancy stuff really. That's, for example, what this will do is take all JPEG files in a particular location and convert each one using convert. Okay, so if you wanted to put this kind of functionality into a C program, it would be kind of painful and you'd have to maintain it and all that. Instead, we avoid all of that by making the C program nice and simple, and then the script does some of the more complicated things actually. And that goes with the philosophy of Unix, that is, you write programs where each program does one thing, and it does that one thing really well. And then you put it together with scripts. Okay, so let's take a quick look at how to run shell programs. There are actually quite a few ways to run things, but here's what I want you to get, is that we want to always end up using something like this. Okay, so we want to write programs that have this is a comment, and then any number of statements, and we want to run it like this, / name of the script. That said, let's take a look at some of the other ways we can do this. So let's write some of these programs and run them, and that way you can see how to actually run these scripts. Okay, so here we are at our bash prompt, and I'm going to set up a very simple script. And this is, it's very nice and easy. Oh wait, let me just go cd into my scripts folder, so I have all my scripts in one place. And now, script 1 will execute the date command, pwd, and ls space -l. And I hit a control D, and I cat my scr1. Okay, there it is. So how do you execute this? There's quite a few ways to do this. One is with the source command, source scr1. So you can see it ran the program. Here is the first line is date. Here's date. The second line is pwd. Here is my the current working directory. The third line is ls-l. That gave us these 3 lines of output. Okay, so that's one way to do it. Now it turns out you don't have to say source scr1 like I did here. You can also say dot scr1. Oops, scr1 does the same thing. So the dot in this context is the same as source. What does that do? It just runs a script. Okay, so here's another way to run a script, and this works. This says run a bash shell, take all of the input from this file scr1, and it does exactly the same thing. So you can try that too. So that's just using input redirection, running a bash shell, getting all of the input instead of the keyboard, getting it from this file. So it's just like you typed in these commands, date, pwd, and ls-l. It's just like you typed it in, instead it's coming from a file. So you can run scripts that way. Let's try another way to do things, that is to start up a bash shell, but execute instead the script one. And once again, it does the same thing, except here in this case it tells you, okay, the first thing that I'm going to do is execute this date command. So it says plus date, and then it shows you the output of date. This is a little bit better because you sort of see what it is that the commands are that generated this output. pwd and ls-l. Okay, so there are actually quite a few ways to run scripts, but the next way that I'm going to do things is what I would prefer, and this is what you want to do for the rest of the semester, for all your labs and all your assignments. You want to set up script files that are set up like this, what I'm going to show you next. Okay, so I'm going to vi scr1. So if these are your commands, what you need to do is first put in what is basically considered a comment, but it's used by the system, that is the whatever shell that is that you're using. You put in a £, which is normally used for comments, but then on the very first line, if you see a bang or an exclamation, then the next thing that the system sees will be taken as an executable or an interpreter that will execute the following lines of code. Okay, so I'm going to write this as scr2. Okay, and I'm going to quit. I know I want to quit because I wrote the file, I saved it, I believe. Let's just try it out. There's scr1 and scr2. So let's cat it out. scr2 has that first comment / path to the interpreter. So that's really what this is saying. This is saying this file has commands that should be interpreted by the bash shell or the bash interpreter. So now how do you run this? Very simple. You have to change permissions. You have to change the permissions so that this file is executable. And then how do you run it? You just, like you would a C executable file, you say scr2, and there you go. So this is the way that you will want to set up script files from now on for all of the labs. That is, you have to have explicitly say what is going to interpret the program and then have all of the commands.